Welcome to Activity 5.1 from our books and revisiting the bouncing ball. So our learning target today is we're going to start figuring out why, from an energy perspective, a ball stops bouncing. So the expectation for you is to complete the energy charts and questions on pages 43 and 44. Now, what have we learned so far in the book? One, we learned how things move. We talked about kinetic energy. We talked about how one type of energy can easily be converted into another type. So for example, from GE to KE, or KE to GE, or KE to EE and back. And we talked about how things bounce, and we looked at why things bounce. So what we're going to be doing now is we're going to be heading towards looking at why things stop. So we know why things start moving, but why do things stop? So the first thing I want you to do is I want you to think about the similarities between the energy conversion diagrams for the bouncing ball, for the pendulum, and the rolling can. So in order to do this, flip back to page 30, and then page 34 and page 37, and try and put your fingers on each of those different pages so you can quickly go back from one to the other. And you're going to pause the video, but when we restart the video, I want you to have some similarities. So go ahead and pause the video. All right, now here's my question to you. If I was watching you, so look up at me. Am I watching you? Did I see you turn to pages 30, 34, and 37? Or are you just trying to skip over that to save time? So if you look up at me and I'm looking back at you and I'm giving you that look, that means I saw that you did not turn back to page 30, 34, and 37. Or if I'm giving you a nod of approval, it's like, yeah, you did turn back to those pages. Great job. So what were some of the similarities that you found? One, they're all represented as pie charts. Another similarity is that all these pie charts describe conversions between different types of energy. The segments in the pie charts represent different types of energy. The sizes of the segments represent approximate amounts of energy. They're not exact. We don't know exact percentages. The size of a pie diagram doesn't change for that, so if it's looking at position 2, it's not going to change from the next time to the next time, That's the way it is at that position. So can you explain why the size doesn't change? Can you explain that the types of energy, can you be able to explain why the energy is not changing from one to another at certain spots and why it's always the same, say at position 2? And what would different size pie charts represent? So can you explain these things? And if you can explain these things, boom, that means you're getting what we're trying to teach here in class. So I'll be able to answer those questions when we go over the lab. So what I'm going to do is I'm going to show you two videos. The first one is a bouncing ball video, and these are the things I want you to look at. One, what did you observe? So we'll be able to talk about that when we go over it in class. Two, how did your observations differ from what you experienced? And three, have you ever seen a ball return to the original height from which it was dropped? So the first video is called Bouncing Ball Video. It's not very long. So here it is. Wow. Let's play that one more time. That's definitely a different video. So my question to you is, what did you observe? Is this what you typically observe when you see a ball bouncing like that? And have you ever seen a ball return back to its original height, way up on top? Now, if you were able to answer all these questions, you were probably pretty quickly able to figure out that they were actually playing the video in reverse. There's no way if you drop a ball from a ladder like that, first of all, don't go on a ladder in here because it's unsafe. But if you were to drop a ball from a ladder like that, is the ball really going to bounce way back up to its original drop height? Probably not. Now here's another interesting video. This is not a ball bouncing, but it's another ball hitting another ball playing pool. So see if we can get that video up. So here it is in slow-mo. So, oh, let's play it once more. What happened to this ball right here? So be able to explain what happened and why that happened when we discuss the lab in class. So Well, I already showed you the bouncing ball simulation video. So this is what you need to do. Why do you think a ball stops bouncing? So when you look on page 43, pause the video and answer that question. Why do you think a ball stops bouncing? So again, I'm going to be looking at you. Did you really pause the video, or are you going to watch the whole video, close your book, and then do it? So make sure you're following directions. You're pausing the video right there. You're answering that question. So this is the diagram that you see here. Now for number 2, it says that your teacher showed you an animation of a ball bouncing until it stopped. And I showed you that. That was the bouncing ball video. So what you're going to have to do now is tell me, what types of energy do you think the ball had at points 1 through 7? So in your book, you're going to see a diagram that looks like this. So at point 1, right here, what type of energy do you think the ball had? And you should be able to answer that based on everything we've done so far. Now at point 2, what type of energy does it have? At point 3, at point 4, at point 5, at point 6, at point 7. So at this time in our unit, you should be able to answer all those without having lots of questions for me. So this is when the ball is yet to be released. It's being held, or it's the instant. It's in the same spot where it is being released. And this is your bounce. This is your full height, and it bounces, full height, bounce, full height, bounce. Now keep in mind that we went to 2 to 3 to 4, but now we skipped these down here. So think about this. The next thing you have to do is tell me, what kinds of energy conversions are there? In other words, if you went from 1 to 2, what type of energy conversions do you have? When you go from 2 to 3, 3 to 4. Now here's where it gets interesting. Remember, 3 was here, but there is nothing right here or right here. So when we go from 4 to 5, and you see that in the chart here, 4 to 5, what type of energy conversion do you have that starts here and goes from here all the way to here? So it might not be as simple as you go from this to that, but you might have 3 different things happening here. You go from this to that to that. So see if you can answer those. Now, once you get those answered, I want you to flip the page over, and I want you to complete questions 3, 4, 5, and 6, and complete the conclusion. So when we go over this in class, I would expect everybody to be done. And I also expect everybody to be done within about 5 minutes of each other, because if you're all watching a video, you're all doing this lab, you should all be able to complete it at approximately the same pace. If you have any questions, as always, come up and see me. Don't just raise your hand. Don't sit in your desk saying, thinking you don't know what's going on, and then at the end you say, well, I never did the lab because I didn't know how to do it. Well, one, did you watch the video and listen to the directions? And secondly, did you come up and ask for help? So again, make sure you come up and ask for help if you have it. So good luck with this lab, and again, make sure you ask questions if you have any.